Hey guys, we are going to do lesson 8 of module 6. So hopefully you have your module at home with you. If not, I emailed you a copy that you can print off or try to do on the computer. But we are on page 33, and before we got out on this crazy break, we had done lessons 6 and 7, which are scatter plots 1 and 2. So we're going to continue with scatter plots today. So let's look at number 1. Scientists are interested in finding out how different species adapt to finding food sources. One group studied crocodiles to find out how their bite force was related to body mass and diet. The table below displays the information they collected on body mass in pounds and bite force in pounds. So if you see here, we have the different species of crocodile, body mass, that's how much they weigh, and bite force, how strong their jaw and their bite is. As you learned in the previous lesson, it's a good idea to begin by looking at what a scatter plot tells you about the data. The scatter plot below displays the data on body mass and bite force for the crocodiles in the study. Okay, so if you guys notice here, our x-axis is their body mass, and then our y-axis is their bite force. So it says, describe the relationship between the body mass and the bite force for the crocodiles shown in the scatter plot. And I hope everybody's noticing that it looks like we do have a relationship here, right? It looks like the more these crocodiles weigh, okay, so if I go up on my x-axis, then the stronger their bite is, okay? And so that's called a positive relationship, positive linear relationship. And on this app, when I do a dot for my eyes, it does not show up. So that's why none of my eyes are dotted. I actually am dotting them and they do not show up. All right, let's go to B. Draw a line to represent the trend in the data. Okay, so we're gonna draw our best fit line. If you are at home and you have this on a piece of paper on your module, you want to use a straight edge. You can make a straight edge by folding any other piece of paper, okay? Or obviously if you do have a real straight edge, like a ruler, that would be great. I do not, so I'm going to do my best on this iPad with my finger to make a nice straight best fit line. Okay, remember when you make your best fit line, you want it to kind of go through like the center of all of the dots, sort of the centralized location of where all these dots go. Okay, so I'm gonna make my best fit line. Okay, not too bad. All right, based on your line, predict the bite force for a crocodile that weighs 200 pounds. Okay, so we're gonna use our line that we drew. We're gonna go to 200 pounds. We're gonna go up to our line. And then we're gonna go over to the y-axis. So this would be, I can't really see this because I drew over it. Looks like about 700 pounds. So I'm gonna guess about 700 pounds. Oops, it was supposed to be 220. I read that wrong. Hang on. $220. Okay, so maybe right here. Oh, it's a little bit bigger then, isn't it? About 800. Okay, so I will say for a croc that weighs 220 pounds, the bite force is predicted to be about 800 pounds. How does this prediction compare to the actual bite force of a crocodile in the data set that weighs 220 pounds? Okay, so let's go up to our data set. Look for the crocodile that weighs 220 pounds. It's right here, crocodile G. And that crocodile's bite force was 1,000 pounds. Okay, so it was a little bit higher And if you notice, we also had crocodile, the Indian gharial crocodile that was 225. That's really close to 220. And that was only 400. Okay, so this is why we use a best fit line. Both of these guesses are just a little bit off. Okay, so we don't want to use the actual example. We want to use our line that kind of predicts it more accurately of what it should be. Okay, all right, let's move on. What is the equation of your line? Based on your equation, what is the prediction for the bite force of a crocodile with a weight of 200 pounds? Okay, so let's go back to our line. We're going to write an equation. And so to write an equation of a line, we need 2 points on this line. Okay? All right, so I'm going to try to find 2 good points on the line. I think I want to use this point right here. So let me try to find that in the data set. That should be this point right here, 325, 1200. Okay. And then I think I'm also going to use one of these points down here in this cluster, since my line goes right through that cluster. So I think I'm going to use this one right here, 130, 500. Okay, so 130, 500, 325, 1200. 130, 500, 325, 500. Oops, 1200. Okay, so I'm going to write the equation of my line. First thing I want to do, make a 6-pack. So I have 325. I'm putting my bigger point on top, putting my smaller point on the bottom. I'm going to subtract and subtract. Okay, so first one, I have 700 here when I subtract. Other one, I have 195 when I subtract. And now my slope is going to be those 2 numbers. On a fraction, make sure that your y is to the sky. Okay, and when I put it into my calculator, I get 3.58974,359. Okay, so I'm just gonna do, this is about 3.5, okay? And it is okay for us to estimate on this because this is a best fit line. So it's already an estimation, okay? All right, now we're gonna find our B. So we're gonna pick one of our points. I'm gonna use this one. So this is my X, this is my Y, and I'm gonna do Y equals M. Man, these dots, I tell you, there we go. And then X is 130 plus B. Okay, so 3.5 times 130, that gives me 455. 500 equals 455 plus B, minus the 455 from the 500, and I get 45. Okay, so my final answer, my line is, I don't really have room, I'm gonna squeeze it over here. Y equals 3.5x plus 45. All right, let's go to number 2. Several students decided to draw lines to represent the trend in the data. Consider the lines drawn by Sol, Patty, Marissa, and Taylor, which are shown below. For each student, indicate whether or not you think the line would be a good line to use to make predictions. Okay, so let's go through each person's line that we have here. I'm going to start with Sol. Okay, so Sol's line is the upper left. Sol's line is not terrible, okay? Here's the problem with Sol's line. There's too many dots on the top of this section and then on the bottom of this section. So you notice how on each one of these sections, there's not dots on both sides. Okay, so I'm going to say there are too many dots just on one side of the line in each section. Okay. All right, let's look at Patty next. Patty's line. Not gonna lie, I like it. I think it's good. Yeah, you do have this little cluster down here where you say like, oh man, there's all these points down here, but you know what? That's not the majority of the points. The majority of the points, Patty's line fits it, okay? So on Patty's line, I'm gonna say thumbs up. I really like her line actually. Okay, let's go to C, Marissa's line. Oh, Marissa, what a mess. So Marissa's problem is every single point is below the line, okay? There's no points above. They're all below. She does have a couple of points on the line, but overall, just way too many points below. So too many points below the line. You want to have kind of an equal amount above and below. Okay, and then let's look at Taylor's line. Taylor's line is last. Taylor's line, you know what? If it didn't have these 4 points, it would be a pretty good line. But I think those 4 points at the end kind of need this line to shift up a little bit. So I'm going to say for Taylor, pretty good, but maybe it needs to be tilted up a little bit. Tilt up a bit to make it fit the data at the end. All right. By the way, I crushed that thumbs up that I drew with my finger on the iPad. I'm not mad about it. All right, let's move on. Number 3, Nora drew a line she thought was close to many of the points and found the equation of the line. She used the points 13, 6,000 and 7, 12,000 on her line to find the equation. Explain why picking those particular points made finding the equation easier. Okay, so when you're picking the 2 points on your line to draw the equation, to make the equation of your line, you can really pick any 2 points that you want. So they're asking us, why are these points great? And I'm going to tell you why. Number 1, they're nice, round, even points. 6,000, 12,000, okay? Number 2, and I'm going to actually start doing B while I show you this. When you do the slope of these 2 points, 13, 6,000, 7, 12,000. When you do this, you get negative 6,000 and you get 6. When you divide those, wow, what a nice round number we get, right? Negative 1,000. It's not a crazy decimal. It's just a nice, neat number. So the reason why those are great points is because they're nice round points and they give you a nice round slope. So here's the point. When you are picking your 2 points, spend a little bit extra time picking points that are going to make your life easier. And then the rest of the problem goes much quicker and much easier for you. All right, we found our M. We're going to go ahead and find, oh wait, we should probably write something down for A. So let's write, they are nice round points and make a nice even number for M. All right, we're gonna go ahead and find our B now. So on part B, let's write down y equals mx plus b. We are going to find our B. We want to pick one of our points, doesn't matter which. I'm going to do the 13, 6,000. Okay, so there's my x, there's my y. Plug them in. So we have 6,000 equals negative 1,000 times 13 plus b. Okay, so this gives me 6,000 equals negative 13,000 plus b. I'm going to add the 13,000 over. So I get 19,000 equals b. And now I'm ready to write my equation of my line. Y equals negative 1,000x plus 19,000. All right, C. For which car in the data set would the predicted value based on the line be furthest from the actual value? Okay, so basically they're saying, listen, we wrote this great line. We made this best fit line. Is there a car on here that's really far off? And the answer is yes. We have this one car down here. It's kind of an outlier. Okay, and so this is talking about the price of a car and the age of a car. Okay, so they're saying this car, most cars are going to start out around $19,000. They're going to lose about $1,000 a year in value. So this car is way off. It's 10 years old, but it's worth only $4,000, whereas other cars similar are worth like $9,000, okay? And so let's write down the point that we have. Which car? So we're gonna say the 10-year-old car worth $4,000, way off. And you know what, guys? Maybe the people who own that car really put a lot of miles on it. Maybe they got in an accident. Maybe it's one of those cars that like, it's just super trashed, right? Maybe it's just totally beat up inside. Who knows? So there's lots of reasons why a car might be worth less than what it should be worth. All right, let's go to the last one. What does the equation predict for the cost of a 10-year-old car? How close was the prediction using the line to the actual cost of the 10-year-old car in the data set? All right, so we're gonna do a 10-year-old car. So we're gonna plug in 10 years for our X. We're using our equation from B. Okay, so this is negative 10,000 plus 19,000. And that's $9,000. So it should have been worth 9,000. And it was actually worth 4,000. So it's pretty far off, All right, you guys are going to be trying the 6.8 homework this week. Okay, and that is page 36 and 37, and then you're gonna stop. Okay, so 36 and 37, you're trying that. Please text me or call me or email me if you need any help, and make sure that you complete this homework this week so that you can get some credit for math. And I will talk to you guys soon. Take care.